Let me check if my stream is live. Hello. Let me check if my stream is live. It works. So today we will be studying bit manipulation. We have 8 problems, then 5 problems, then 5 problems. I'll wait for some time for the link. Okay, first 3 problems are theory. Let's start. Given a 32-bit unsigned integer and unsigned integer, I perform the following operation: get the ith bit, set the ith bit, and clear the ith bit. Note: for better understanding, we are starting bits from 1 instead of 0. You have to print space 3 space separated values. So now without a line break, do not have to return anything. $70 and 3. So third bit of 70. Explanation: the bit at the suboriginal is, so this is 70, 0, 2, 4, 8, 16, 32, 64, 64 plus 4, 68, 69, 70. So the bit at the third position from left, 1, 2, 3, is 1, the value of the given number after setting third bit. Given number after clearing the third bit is 66. Okay. 81 output 098. First we have to get the ith bit. So in order to get the ith bit, we can AND it with 2 raised to 3 minus 1, 2 raised to 2, 2 raised to 3 minus 1. So first I will have to print ith bit is equal to num and 2 powered I minus 1. Then we have to set the ith bit. If ith bit is equal to 1, set I'll keep set bit as the number itself. If ith bit is equal to 0, if ith bit is equal to 1. What does that mean? If ith bit is equal to 1, then we don't have to do anything. But if ith bit is equal to 0, then I'll add something to the number plus equals to we are increasing the addition by ith bit, right? So 2 raised to I minus 1. So first we are done clearing the ith bit, and in order to clear the ith bit, clear bit, let's keep clear bit as what? Clear bit as 0, and if we can do this inside this loop only. Clear bit minus equals to print ith bit your output, expected output was 1. Okay, what were we supposed to return? Two raised to I is 4. Wait, what did I end it with? Get the ith bit for 70. We wanted this bit, so we will put a mask that will have 0 0 0 0 1 0 0, and that will give me 4. Oh, okay. So if this is greater than 0, then answer is 1. It is equal to 1 if is greater than 0, else 0. Let's go. Now let's see how these guys have done it. We strongly recommend setting a bit means get bit is 0, then set it to 1, else if it is 1 then leave it unchanged. We can create the bit mask using left shift operator and then perform the bitwise OR operator. Wait a minute. Setting a bit in C. Setting a bit. Bitwise OR with mask. What have they done? K minus 1. What's the mask here? Original number 1, bit position 1. Original number is 5, bit position 1. So 5 is written as 101, bit position is 1, so 100 101. 5 with ith bit set is 5, yeah. 5 with I bit cleared is 4, 100, and then 5 with I bit toggled is 4. So first what I am doing is just setting the ith bit. Bitwise or with the mask. Return n is 101 or 1 shifted to the 1 is 1 is shifted to 0, 1 is left shifted. Okay, so if we do or 1 and 1, but will it work for, instead of this I'll try this. Ith bit is equal to n number 1 I minus 1. Output is 70. From the right, so we're targeting version 5 bit position y1 101 001. It's already set, so clearing this, multi-seed for k is equal to 3. Okay, so 5 is equal to this and then this, so this or this will give me 13. That's wrong, right? Of course it's wrong. After setting k is equal to 3, 0 1 2 3 0, no, not right. One left shifted twice. K3 now. 1 2 3. Setting the first, second, third bit is already set. Is 4. Five with third bit set is 13, but third bit is already set, no? चैट जीपीटी शाना हो गया भाई. You know, say even though is equal to 4, the OR operation doesn't change the number because that bit is already 1. Stupid. K is equal to 1, K is equal to 2 में क्या होता है, 7 हो जाता है, right? K is equal to 3 में set bit 5, 3 is equal to 5. 5 or 3 is 7. What is 5? 0 1 or 3 is 0 1 1. Should be 2. This should be 7. This is 7. This is 7. This is 5. This is 7. Achha, this is 7. One left shifted by 1. This is 1 left shifted by 1 now. This should be 7. Oh. Okay. Not C, bro. Num left shifted to I. No, this is right shifted. Num right shifted to I, and then doing AND with an. Oh, okay. Have they done the same thing in this? Right shifting num to I, and then doing one set bit, setting bit num or this to I, clearing bit num and not I, and in pattern you don't need to worry about unsigned or overflow. Integers arbitrary precision. Okay, moving forward. Where are we? Second question. Kth bit set or not? Kth bit is set or not? Checking if kth bit is set or not. We will just kth bit. So checking if 1 2 3 fourth bit is set or not. I'll shift this by shift nums by to the right by 1 2 3 places. I minus 1 place, 3 places, and it with 1. If it is 1, then yes, if it is so return and right shifted by key minus 1 and 1. For input 4 and 0, your output with negative shift count. What do you mean? Negative shift count. What did I do wrong? Let's read the question first. 4100 k is equal to 0. 0th index from LSB is not set. Oh, it is 0 based. zero waste. So if it is 0, no shifting. If it is 1, then I'm shifting by 1. So n okay, this is right. Check if a number is odd or not. Positive integer determine whether it is odd or even. Return true if number is even. So if the number is odd, then last bit will be 1. So I'll just add that number with 1. If it is true, it will give me 1. If it is 0, it will give me 0. Then n and 1. And 1. 0 and anything is 0 anyways, no? For input 4, or is 0, 1 0 0. When I AND it with 1, the answer is 0. Sorry, I'm ANDing it with 0. So 0 and 1 is 0. And it with 1. Let's see what their editorial says. Okay. Check if a number is power of 2 or not. Given an integer and return to hit the power of 2, otherwise return false. So what does power of 2 mean? If any number is power of 2, then this should be the format of it, if it is a power of 2, right? Which is written 2 raised to 31. 2 raised to 31. So I can take the longest number I know, and if I do, suppose this is my number, so let's do and should give me Is there any other technique? With whom do I end it in order to give me? Okay. Instead of that, what I can do is let's check if odd places are 0 or not. So I'll take a num. I'll check if it is 0. Num, I'll AND it with 0. If it gives me 0, then I'll right shift num by 2. I'll do this till while num is greater than 0. Num and 0 0. If num and 0 is 0, then I'll continue. And if num and 0 is not 0, then I'll return false. While num is greater than 0, if num and but I have to just see the last place. Num and 1. Let's do num and 1 because we care about the last place. If num and 1 is equal to 1, then this is return false because last bit is a1. And then we'll do right shift num. After all this, return true. Cannot access local variable num. Output is false. Is output false for 16? What is 16 written as? 2 raised to 0, 2 raised to 4, 6, 2, 4, 8, 16. So I'll AND this with 1. What will this give me? This will give me 0, which tells that this is 0, and with 0, sorry, AND with 1, then AND it with 1. What am I doing? When I AND it with 1, 2, 4, 6, 8, done. 16, 8, 4, 2, 0. I'll AND it with 1. So if this was 1, it will give me 1. If it was 0, and check. Oh. If is equal to 1. If this was 1, then this could have been 1, right? But this is 0. Now I'll right shift by 1 2, so it will be 1 0 0. Again the answer will be 0. Then again I'll left shift by 2, right shift by 2, then 1 0. The answer will be 1. Bruh. This should be 0, is it? What is this? 2 raised to 0. What am I doing wrong? 2 raised to 1. I don't think my logic is right. Oh my god, everybody is a multiple of 2. Let's see all the numbers from 1 to 9. 0 1 2 3 4 5 6. Oh my god, we only care about power of 2. This is for 2 power 0. This is 2 power 0 to 1. 2 square is 4. 0 1 2 3 4. 2 power 3 is 8. 4. What is 8? 0 1 0. So 0 1 1 0 0 0 1 0. What are the constraints? Oh, n is negative. So one thing is, if n is negative, or equal to 0, then I'll return false straight away. And when do we say that n, suppose take an example of 8. 8 4 input is 2 0 0 1 0. Okay, so only one bit is 1 in case of this. Then how do I so if I do n what is 1 0 1 0 8 9 10? It is 10, but 10 is not a power of 2. Why is it not a power of 2? What is 9? 7, what is 7? 6, no, 4 5 6 7. This is 7, right? This is 8. Okay, this is 9. This is 10. So 8 is there because bits get inverted. So if I add this, and 8 and 7 will give me 0. So if number and number minus 1 equals to 0, then true. 10 and minus 1 equal to 0. Good. Now let's see the editorial. Nice. So this is the logic behind this problem, n and n minus 1. Count the number of set bits. Is equal to 4, output is equal to 5. Start another question. Output is equal to 4. Input is 4 and output is 5. The numbers from 1 to 4, set bits from okay, let's draw the numbers again. This is 2 3 4 5 6 7 8 9. One, 2, 3, 4, 5, 6, 7, 8, 9. So if we are counting till 3, 1 2 3 4, 1 2 3 4, we learned in the last answer that this will be always full. So if we are calculating it till 8, then 8 and 7 will be 4 bits, and then what changes? Four and 5 becomes 6, 6 and 7 becomes 8, 8 and 9 becomes 10. No. What is 10? 8. This is a bit tricky, man. Given a number, find the total count of set bits for all numbers from 1 to n, both inclusive. Then complexity is of log of n. Of log of n. Set bits 4. Can we find anything by left shifting? What happens when we left shift a number? Let's say we left shift this 10 by 1, right shift this 10 by 1. Then we get 0 1 0 1 1 0 1, that is 5. Okay, we are dividing it by 2. The 5 I left shift, it will become 1 0, for that is 2. So right shifting gives us division, double divided. This. Does this signify anything? Between this and this, we have 1 2 3 4 5 6 7 8 9 10 10 bits. So between this and this, are there 5 bits? 1 2 3 4. No. What was this? 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9 10. 10 9 8 7 6 5. Okay, so 5 4 3 and 1 2 3 4 5. 5 bits here, 10 bits here. So one more thing. Oh, so what does this tell me? So if I'm given number 10, then I right shift it by 1, then I'll get 5, and in the answer I'll add 10. Then again 5 I'll right shift by 1, I'll get 2, and then the answer I'll add 5. Now we are at 2 now. So 2 is 0 1 0. I right shift by 1 gives me 1. That is this. But here gives me 2. If 2 I right shift by 1, it will give me 1 0 0 1. And how many are there? There is just 1 bit instead of 2. And 1 I right shift by 1 give me 0. Let's try this logic and see where we go. While n is greater than 0, what I'll do is Nah. No. I knew it won't work. Let's go to the editorial. Okay. One set bit, two set bit, one set bit. Therefore, total is 5. Root 4. Idea is to calculate set bit for all numbers 1 to n. Okay, count is equal to 0. Run a loop from 1 to n. Now for every number, and it with 1. For every number x, run a while loop till x is greater than 0 and it with 1. Increase the count by 1. Because in any number, if we perform bitwise operator with 1, if its last bit is set and then gives 1 else 0. Every time divide x by 2 for the right shift x by 1 time, so that the next iteration we can check the next bit is set or not. For I is equal to 1 to n, so we are taking 1 at first. X is equal to I, x is 1. Okay. While x, so while say 5, we are counting till 5 and say we are at 5. So while 5, if 5 and 1 is equal to 1, count plus plus, and then I'm dividing by 2. That is, I'm checking the next bit of it, right? Yes. So this is the brute force approach, checking all, but we don't want this. Check the patterns of binary representation. Notice that alternate bits in A are set 0 1 0 1. Every 2 alternate bits in B are set, every 4 alternates in B are set. This will keep on repeating for the every power of 2. So we'll iterate till the number of bits of n. We'll add 1 to the number in order to compensate 0, as the binary number system starts from 0, not n plus 1. So we will track the number. If x double divided by 2 is less than n, what is n? X is equal to 2. Okay, this is some serious math. Let's check back to this. What's happening here? Repeating alternate times. So if I'm given a number, say 6, if I'm given a number 6, so what happens here? So the bits here will be exactly 1 2 3 7. It will be 3 2, so it will be 6 modulo 6 divided by integer division of 6 by 2 will give me this bit place. Okay, in order to calculate for this bit, 1 2 6 we are divided by 3, 2 3. No, 1 2 3 4. 1 2 3. This is still 5. Okay, this is 6. Stupid. 1 2 3. 6 divided by 2. 1 2 3. 1 2 3. Let's take 9. Sorry, let's take 9. So for 9, looking at the 1 2 3 4. So 9 divided by 2 is 4. This is for units place. Then for this 1 2. 1 2 3 4. For this also it's 4. How? Is it 9 divided by? It's still divided by 2. But here it's 2 3 4. But here we have one extra. Okay, so why do we have all this? So we have 9 double divided by 2 3 times, because 9 is greater than 2 raised to 3, right? So we have full, and then we have left 1. So that 1 will be 9 itself. This is 9. Oh shit, this was 8. Well, never mind. Let's go and ask ChatGPT Devata. Explain. Highly optimized approach to count the total number of set bits in a binary representative of number 1 to n. Far better than brute force. So set bit is 1. So 1, there are 2. 1 2 total set. Instead of checking each bit of each number, the algorithm counts the set bit column by column. Okay, that was one thing which I understood. From left to most significant bit. Core observation: every bit position follows a pattern of zeros and ones. Every 2 raised to I step. 2 raised to, for first column it's 2 raised to 1, that is 2. 2 raised to 0 step, so 1 step. After every 1 it's changing. After every 2 it's changing. After every 2 it's changing. Code explanation: because we want to include n itself, original code counts from 1 to n include. N plus equals to 1. What do you mean? quant is 0. X represents the current block size. So now for each bit position, while x by 2 while x by 2 is less than n, and x by 2 is less than n, split the range of n into full cycles of size x. Quotient is equal to n by x. Quotient is equal to n by x. Count is equal to, where's my phone? Hooligan, are you watching the live stream? What is happening here? We split the range of n cycle into full cycle of x. Range of n because include n itself. I don't know what they are saying. N फिर n ला लिया इसने. Yes sir, nice. So you understood the problem, na? Counting the set bits from 1 to n. Increment n to include it in the count, since original counts from 1 to n inclusive. So why did we increase n is plus equals to 1? Let's see the question. Question यहाँ पे 4 output was 5 from 1 to 4, so this is for 1 2 3 and 4 set bits. Input n, so why did we increase n plus 1? n plus 1 क्यों किया भाई? Okay, anyways, total set bits is equal to 0. Final result, this will increase slowly. Power of 2 is equal to 2. Tracks the current bit position block size. 2 4 8 16. Power of 2. Okay, while power of 2 modulo 2 is less than n. So first let me do this mathematically. Power of 2 modulo 2 is less than, for 4, n was 4, this is a question, is less than 5, while n double dot divided by 2 is 1 0 sorry 1 and double divided by 2 is 1. Power of 2 divided by 2 is less than n. Full blocks, number of complete blocks of current size. Example, for power of 2 is equal to 4, for power of 2 4, power of 2 क्या लिया हमने पहले? Power of 2 2 लिया था. For what? For power of 2 is equal to 4, block is equal to 0 to 3 4 to 7. क्या बोल रहे हो? This is going over my head. For power of 2 is equal to 4, blocks is 0 to 3. 4 to 7. Variable meaning count. Total stores the final sum x power of 2. Power of 2 tracks the current block size. What do you mean by block size? The context of counting set with effective block size refers to repeating patterns of 0 and 1. Okay. Each bit column wise. Each position I has cycles of zeros and ones that repeats every 2 raised to I numbers. So for position 0, 2 raised to 0, 1. So for last, this repeats after every one step. Okay. For first position from the left, it repeats after 2 raised to 1, 2 steps. So 0, 0, repeat, 1, 1, repeat. Okay. So when we say block size, we mean the length of one cycle of 0 and 1 for a given bit position. So for a given bit position, say bit position 1. So these are the bit position 1s. Here the block size, the length of one full cycle of 0 and 1s. One full cycle of 0 and 1 will be 1, 2, 3, 4. It will be 2 raised to not 1 but 2, 2 raised to 2. Here it's 4 times. Here it's 8. That is 2 raised to 3. Okay, 2 raised to 1. This is 2. So block size is 2 raised to n, na? Let's say n is equal to 7 1. Let's look at the bit position 1. For bit 0, the pattern is 0 1. Repeats every 2 numbers. Block size is equal to 2. Okay. 2 raised to 2. For bit 1, it will be 2 raised to 2, 4. Block size is 4. Just 8. 4 set bits. So why are we counting blocks? Because if you know there are m complete blocks of size 2 raised to I, 2 raised to number of bits. Each block contributes to 2 raised to I minus 1 once at that bit position. Is this right? 2 raised to I minus 1. True. True. So we are counting the total number of complete blocks. You don't have to check each number individually. Visual for bit 1, second bit. Bit 1 is this 0 1 2 3 0 0 1 1 and 0 0 1 1. Okay. When n is equal to 7, each block contributes 2 set bits. So okay. So what are we trying to calculate for each bit position? Each block control. So for each bit position, let's say this bit position in the middle, we are trying to calculate how many blocks are there. So this is 1 block, this is 2 block. For 9 there are 2 blocks of first bit, that is this. Then we will calculate this as 2 into how many is the block size, uska half, 2 raised to, so 0 1, 2 raised to 1. Two into 2 raised to 1, this will be the contribution of ith block. This I na. So I have to sum everything up. Now let's look at the solution. Coming here, what are we doing here? Loop until bit position exceeds n. Full blocks is equal to n divided by power of 2. Okay, n divided by power of 2 will give me 4. Total set bits plus equal to half block size 100 bit position. Full blocks into power of 2 divided by 2. How many full blocks are there? 3. Right? Oh, I did this calculation. Full blocks multiplied by power of 2 divided by 2. Wait. Their power of 2 is not 9. Achha, they're starting from 2 and then they'll multiply, I guess, ahead. Then remaining numbers outside the full blocks left over is equal to n modulo power of 2. Okay. इसको भी रब कर देता हूँ. So first we'll take 2 size and then we will check on n is 9 na? So what we first checked, increment and to include तो n को कर दिया 10 for some reason. Who cares? We will understand it after some time. Okay, 9 को कर दिया 10. So while power of 2 divided by 2 is less than n, so 2 divided by 2 is 1, while 1 is less than 10. For the first block I will take how many? Total set bit plus equal to full blocks, full block calculation is equal to 2 divided by power of 2, no, n divided by power of 2. So 10 divided by power of 2 will give me 5. So first it says that there are 5 full blocks for this. Is it true? 1, 2, 3, 4, 5. Okay, there are 5 full blocks. Now I'll multiply that 5 with power of 2 divided by 2. 2 divided by 2 multiplied by number of blocks, that is 5. 5 2s are 10. No, 5 1s are 5. So this will give me this. So total bits plus equals to 5. Total bits will be full blocks into power of 2 divided by 2. Okay, now remaining numbers outside the full block will be n modulo power of 2. So 10 modulo power of 2, 10 modulo 2, what is 10 modulo 2? 10 modulo 2 is 0. So there are no leftovers here, right? Okay, that is done. And then if leftover exceeds the half, if leftover exceeds half the block size, add extra ones from the remaining part. Okay, if leftover exceeds half, if leftover is greater than power of 2 divided by 2, leftover is greater than 1, then total should be leftover minus power of 2 divided by 2. Okay, because the first half of a cycle consists of 0 0, and second half will consist of ones. So that is understood. And then we again multiply power of 2 by 2. So now we'll make power of 2 by 4, which means that we are checking it for this. So here 4 1 1. So again what we'll do is we will divide the number by 4. So 10 double divided by 4, what does it give? 2. This gives 2, because we have 1 2 full cycles, right? We have 2 full cycles. So again what we do, 2 multiplied by, in 2 cycles how many we have? We have power of 2 double divided by 2. Is it true? Full blocks into power of 2 double divided by 2 will be add to total bits. So yes, this is being added till here. And then now in order to find leftovers, I'll do 10 modulo 4. 10 modulo 4 will give me 2. Remainder is 2, not 10 divided by 4 modulo 2. So is 2 greater than the is 2 more than half of this 4? Because whenever 4 are there, it will be 0 0 1 1. This won't matter, but this will matter. So if leftover is greater than power of 2, and then if leftover is greater than power of 2 divided by 2, total set will be leftover minus power of 2 divided by 2, and then I can multiply 2 until where we are going, while power of 2 modulo 2, sorry, double divided by 2 is less than n. What is power of 2 now? Right now 4 modulo 2 is less than 7 9 10. 2 is less than 10. After this, what I'll do is power of 2, I'll double this 4, not double, I'll square this 4. It will be 16. 16 modulo 2 is 8. It is less than n. And then so now let's try solving this on what we have learned. सर मैं लोबनॉक्स खेलने जा रहा हूँ. ठीक है सर. Thank you for watching the stream, hooligan. So I don't know why we did this, but n plus equals to 1 is what we did in the start. After that, I'll take a power of 2. Power of 2 is equal to 2 in the start. Then I run the loop till some condition, which I'll write afterwards. Okay. First thing that I do is I'll find the number of blocks of a particular bit. Find number of blocks for a particular bit. How do we find that? So it is based on the power of 2. Power of 2. So power of 2 divided by 2 will give me the block size, right? So what happened here? Now we will find the number of blocks. Blocks is equal to the number that we have divided by power of 2. So total bits is a variable which I'll update slowly. Total bits plus equals to number of blocks, and in each block how much will I have? each block I'll have half the size of power of 2. Power of 2 divided by 2, right? So I have found total bits. After finding the total of bits by the blocks, I'll find leftovers is equal to, I'll take n modulo power of 2. So after doing this, I'll find leftover. So if leftover is greater than half of my block size, if it's greater than half the block size, then I'll add total bits plus equals to leftover minus later half of the block size. After doing this, I will increase the power of 2. Power of 2 multiply equals 2, and this will go on, but till when? So this will go on till my n power of 2, till n divided by power of 2, no sorry, power of 2 divided by, till my power of 2 divided by 2 is less than n. After this, I'll return total bits. I don't know if this is right. Block is not defined. Either block. Your output 10, expected 5. What's happening here? Double क्यों हो रहा है? Total bits plus equal to blocks into power of 2 divided by 2. Is this correct? Power of 2 is 1. Total blocks I found 5. So 10 divided by power of 2 is 5. So 5 blocks, and in those 5 blocks I have 1. So power of 2 is 2. 2 divided by 2 is 1. 5 into 1. Total bits were 5 in the start. Now let's take the input 4. So for 4 we'll have 2. Power of 2. 2 divided by 2 is less than 4. Yes. Blocks is equal to 4 divided by power of 2, that is 2. So we have 2 blocks. Total bits in these 2 blocks will be, in each block will have 1. So 2 blocks into power of 2, 2 divided by 2, 1. So total bits will be 2 here. Okay, and then leftover will be n modulo of power of 2. Leftover is 0. Leftover is less than blocks divided by 2. So this won't be added. And power of 2 is multiplied by, is raised to 2. So this is 4, right? So 1, 2. So this is right for us. Now our block size is 4. Block size is 4. Power of 2 is multiplied by 2. 4 divided by 2, 2 is less than 4, yes. Blocks is equal to 4 divided by 4, 1. So we have 1 block, that is right. Total bits is equal to 1 block of 4 multiplied by 4 divided by 2, that is 2. 1 into 2, 2. Our 2 bits here, this is 1 bit, this is 1 bit, yes, right. Leftover is equal to n 4 modulo 4 is 0, no leftover. Now we do power of 2 raised to 2. 4 square 16. Okay, so if power of 2 16 modulo 2 16 divided by 2 is 8. Is 8 less than 4? No. So we have written the answer. Was the answer right? This 2, what about this one? 1 2 3 4. Okay, power of 2 no. Power of 2 multiply equals to 2, no? Okay, it will be 8. Sorry, my bad. Now it will be 8. 8 divided by 2 is 4. Is 4 less than 4? Less than or equal to आना है क्या इधर? Your output is 10, expected is... Huh? What if I don't do this? Your output is 8. One more is required, but I'm doing n plus equals to 1. Then it doesn't work, right? Okay, let's go and check what happened here. Total set bit 0, power of 2 is 2, n plus equal to 1. Power of 2 divided by 2 is less than n. Yes, block is equal to n divided by power of 2. Yes. Total bits plus equal to full blocks into power of 2 divided by 2. Correct. Left over is equal to n modulo power of 2. Right. Left over is greater than power of 2 divided by 2. Oh, blocks divided by 2 किया मैंने. Left over is greater than blocks. Blocks don't matter, right? Power of 2. Power of 2. अच्छा, power of 2 was the size of block. Sorry. Power of 2 divided by 2. Total bits plus left over minus power of 2 divided by 2. What if I don't do this? I check for this. Okay. So we have to increase the number by 1. This was a good question. Counting the total set bits. Revising. Let's go through this once again. For every bit we are calculating how many total blocks are there. How are we calculating that? Total blocks will be n divided by the power of 2. Then we'll multiply the total blocks by power of 2 divided by 2. And leftovers will be n modulo power of 2, and leftover is greater than this. Then total bits, this will be added. We'll increase the power of 2. Now we have to do this till power of 2 divided by 2 is less than n. Power of 2 divided by 2. Power of 2 is what? Power of 2 is the full length size. Power of 2 divided by 2 is less than n. Suppose power of 2 is 16. Power of 2 is 16, okay? And 8. 8 is less than. Let's look at number when n is equal to 9. So n is equal to 9, this is the number, right? And power of 2 is 16, so 16 divided by 2 is 8. So what happens here is, this was for 2, this was for 4, this was for 8 size, ये 4, ये 4, 8, 16. तो अभी क्या होगा, 1 2 3 4 5 6 7 8, and then 1 2 3. But we are taking n is equal to 10 for this bit. So 10 divided by 2, 10 less than 10, 8 is less than 10, yes. अब हमने लिया पावर ऑफ 2 32. Okay, now I understood. So this was count the number of set bits. So thank you guys, we solved 5 problems today. I wish I could have done this, or shall I do this? But if this is hard, then I'll quit it in between. Set and unset the rightmost unset bit. The fuck? Set and unset the rightmost unset bit. Binary representative of 6 is this. Representing rightmost bit, it becomes no. Rightmost unset bit. This is this. After setting rightmost bit, it becomes 31. So what I'll do is I'll try to find which is the rightmost unset bit. Okay. I'll take a variable mood. So one approach came to my mind. The representative, let's say it's 15. This is a good example. 15 is 0 1 1 1 1. Take a variable mood. I right shift this once and do AND with 1. If I do AND with 1, so number n and 1, what will this give me? This will give me 1. So if it is 1, then nothing. If it is 0, if and 1 is equal to 0, then what does it move? Mode is 0. So my zeroth bit was 0. Okay, then I will AND my number. So I will OR my number with then n ORed with 2 raised to 0 is 1. 2 star star mood. But till when, bro? Okay, so this is the logic. I'll store num is equal to n, mood will be 0, while num is greater than 0. Num is greater than 0. What am I doing? N num and n, num and 1. If num and 1 is equal to 0, that means we have found. So we will return return n or 2 or mood. What else? Else I'll just increase mood plus equals to 1. Okay, and if I don't find anything till the end, like in this case we don't find anything till the number becomes 0, then what I'll do is I'll OR it with how much mood plus 1. Return wait a minute, where am I left shifting it? Sorry, right shifting it by 1. Time limit exceeded. Please optimize your code and submit again. Is it because of this? Let's look at the editorial. Wait, I'm ORing with 2 power mood. Instead of 2 power mode, I'll just what is this? This is 1 move to 0 places. This is 1 move to mode. Is this working? Even this geometry, what the? Let's give my solution to ChatGPT. You're almost there. Trying to set the rightmost unset bit to n, which is classic bit manipulation problem. Indentation. Python will throw an error due to inconsistent indentation. Missing alignment. If in number it doesn't actually shift num, since num just returns a value. Oh my god. Let's go. Just 1 equal to, what have they given? Num2 move 0 position 0 while num is greater than 0. If num and 1 is equal to 0, return n or 1 position num, move to the right position plus 1. Good. This is done. Swap 2 numbers. Let's do this also. Swapping 2 numbers. You are given 2 numbers A and B. Your task is to swap the given 2 numbers. Try to do it without temporary variable A and B, and then we'll print 9 and 13 without using a temporary variable. Okay. So okay, swapping. How do we swap, man? I'm watching the editorial right away for this. a is equal to a plus a, b is equal to a minus b, a is equal to a minus b, and a is equal to a, b is equal to b. What? A is equal to a plus b is equal to a plus b, and b is equal to a minus b. A plus b minus b, and b is equal to a minus b. Okay, okay, okay. But how is it done in bit manipulation? XOR. Okay, using bitwise XOR. The idea is to use the properties of XOR to swap the two variables. A XOR B stores the bitwise XOR of A and B, and now holds the result of A XOR B. A holds the result of A XOR B. Let's use ChatGPT to understand this. Explain. A is equal to A XOR B, B is equal to A XOR B, A is equal to A XOR B. A B A. Property X, when same numbers are XORed, it gives me 0. Only when different numbers are XORed, wait, X XOR X is equal to 0, and X XOR 0 is equal to X. It gives me 0 every time. Only when it is XORed with the 0, it gives me the number. Is the property to remember. And commutative and associative. 2 and 3, 2 is okay, 2 is 0 and 0, and this step 1, A is equal to A XOR B. So A XOR B will be when there are different. No, when one of them is 0, it returns the other. So this is 1. When they both are same, it returns 0. So 0 0 1. Okay. A is equal to 1. 0 0 1. B is equal to A XOR B. So XOR of this 1 and 1 will be 0, 0 and 1 will be 1, 0, B is equal to 2. B is equal to A XOR B. Set the A is equal to A XOR B. 0 1. Works only with numbers. Using computer embedded system interview puzzle. Version swapping variables is more intuitive. Like, okay. A is equal A XOR equals to B. A is equal to A XOR B. B is equal to B XOR A. A is equal to A XOR B. Print A, comma B. And tab is not scriptable. What do they want? I don't think they want it in this way. Print string and answer 0. Divide two integer without using multiplication division or mod operator. IPL में क्या हुआ? Mumbai lost. Good. Divide two integer without multiplication division or mod operator. Divide two integers. Given two integer dividend and divisor. Divide two integer without using multiplication division operator. The integer division should truncate towards 0, which means that losing its fractional part. For example, 8.3 would be truncated to 8. Okay, and minus 2.3 would be truncated to 2. Return the quotient after dividing dividend by divisor. So 10 divided by 3 is 3. Okay. So we can't use any operator. So they want us to use R. Bit manipulation. So how do we usually divide it? So in order to divide by 2, we right shift the bits, while num, I'll increase num divided by 2. So let's take dividend is 10, and we are dividing the divisor by 3. How do we do it? What is the range of my divisors? Oh, it's pretty large. In order to divide by 3, what are we doing? 10. How do we write 10? 10 is 8, 9, 10. Right? This is 10. So let's take a big number. 10 divided by 10. Suppose we are doing 10 divided by 10. 10 divided by 11 is how much? 10 divided by 10. This is 10 and we are dividing it by 10. First of all, I'll see how big is 10. So, to see how big is 10, I'll right shift it by 1 every time. So right shift it by 1 year, shift it by 1 year, shift by year, shift by 1. So let's see, we'll run a while loop, while divisor, and I'll do divisor right shift by 1, and I'll increase d plus equals to 1. Okay, d is equal to 0. So after first d हो गया 1, after this d हो गया 2, after this d हो गया 3, after this there is nothing. So d आ गया 3. So it says that 2 power 3 8, 2 power 4 16. So it is more than 8. What does more than 8 means? More than 8 but less than next number. That means this is approximately 2 power 3 plus something 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 is my divisor. Similarly, I'll do for this. It will be 2 power 3 plus something something something. Now 2 power 3 by 2 power 3 will be gone and answer will be 1. Is that how we solve it? Now let's take this as 3. Okay, one example is done. Now let's take 3. So what is 3 1 1 0? This is 3, right? तो मैंने कर दिया लेफ्ट शिफ्ट, बचाइए, डी हो गया 1 और एक बार किया 0 0 हो गया, डी हो गया 2. ओके, तो हो गया 2. सो इट बिकेम 2 raised to 2 4. 4 से ज़्यादा है. ना 2 raised to 1 ही आएगा शायद. 2 raised to 1 and 10 is 2 raised to 3. This goes 2 raised to square to cube. So what are we approximately doing? Doing 8 divided by 2. This will give me 4, but answer is 3. So how do I क्या बोले compensate it? How do I compensate it? Also we can't divide it, right? I think I'm going to the editorial right away. C++ bit manipulation, Python is a solution. Bruh. It's a nope. Bruh. Anyways, sin 0 plus if divided. So power in range 31. Divisor is oh my god. Dividend isn't main. My thinking power is over, guys. Now I'll close the stream. Today we've solved 2 3 4 5 6 7 problems. One more lecture or 2 more lectures, I guess. Thank you for watching. Peace. Let's see if anybody is watching actually. Now